Hey guys, I'm Miuccamatics and welcome back to my YouTube channel Miuccamatics. If you haven't yet hit the subscribe button, kindly do so now. Today I'll be doing the proof of by summation k ranging from 1 to n of k is equal to n into n plus 1 by 2. So basically this is the sum of the first n natural numbers. We can also denote it as Sn. So the proof goes as follows. Let Sn equal to 1 plus 2 plus 3 plus dot 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 plus n minus 2 plus n minus 1 plus n. So basically I've just written it in the expanded form. So the sum of the first n natural numbers, and also we can rearrange this by writing it reverse. So Sn can also be represented by n plus n minus 1 plus n minus 2 plus dot 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 plus 3 plus 2 plus 1. Note that this proof was first given by Gauss when he was a school going boy. This was actually a punishment given to him by his teacher to find the sum of the first 100 numbers. So he did it quickly using this trick. Now adding equations 1 and 2, we get twice of Sn, as it's Sn plus Sn, twice of Sn is equal to, if you notice, each term gives you n plus 1. So this is n plus 1, n minus 1 plus 2 is again n plus 1, n minus 2 plus 3 is again n plus 1, and so on. And this goes on till here. Now if you notice, since there are n numbers, so 1 till n, so the number of elements are basically n minus 1 plus 1. So it just gives n. So there are n elements, so it is repeated n times. So hence twice of Sn is equal to n into n plus 1, and by dividing by 2 on both sides we can write Sn equal to n into n plus 1 divided by 2. Now geometrically it can be shown in this manner. So if I want to find the sum of the first n natural numbers, so 1 plus 2 plus 3 plus 4 plus 5, I'll stop till 5 to show that in the figure. And then I want to show twice of Sn, so I'll again show 1 plus 2 plus 3 plus 4 plus 5. Now if you notice, since this is 1 plus 2 plus 3, 5 elements, so basically this gives you n elements, and since here if you notice there's an additional term plus n, so it is n plus 1. So it's the same expression in the form of a diagram. Now another proof. Sn is 1 plus 2 plus 3 plus dot 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 plus n minus 2 plus n minus 1 plus n. Now if you notice, this is an arithmetic progression with the first term being 1 and the last term being n, and the number of terms are n. Now we know the sum of the terms of an AP is n by 2 into a plus l, first term plus the last term. So it can be written as n by 2 into 1 plus n. So we can, by rearranging this, we can write it as n into n plus 1 divided by 2. It can also be shown using the second formula of AP, s equal to n by 2 into 2a plus n minus 1 into d. Now we know the common difference is 1, as it's the natural numbers. So n by 2 equal to twice 1 plus n minus 1 times 1. So which is n by 2 into 2 plus n minus 1, which is nothing but n by 2 into n plus 1. We sometimes show this as, by opening the brackets, n square plus n upon 2.